Hi, my name is Chris, welcome to my channel. In this one, I will try to emulate an RF remote control with a Digilent CMOD A7 Fpga board. These remotes use an old chip, the PT2262, as a transmitter and PT2272 as a receiver. They have 12 bits of tri-state hardwired encoding scheme that gives a maximum of 500,000 combinations. So, I'll use an FPGA to generate a modulated 319.5 MHz signal by bringing a clock signal to an external wire. This is never a good idea, but that's just an experiment. In my case, only pin 1 and 4 were wired to positive, 9 pins were left floating, and the last one could be 1 or 0 depending on switching. Here is the encoding scheme from the datasheet. I capture with my oscilloscope the waveforms for the on and off states. As you can see, only the last bit is changing. Back to the FPGA project, we use Vivado to write the VHDL code and program the firmware. The remote has an RC oscillator of about 9 kHz, but we only need to generate a tick corresponding to the smallest element in the waveform. So there are two counters, one modulo M to generate a tick, the other counts ticks and selects the output for the on and off signals that modulate the RF signal. But the most important part of this experiment is the 319.5 MHz clock signal, which will simply run through a bit of wire as an antenna. I choose a pin close to the FPGA to reduce PCB effects. Now it's time to generate the bit file and load the design in our board. I should mention that I didn't put any effort in matching an antenna, only a bit of wire or even the oscilloscope probe. Here is my signal compared to the original remote. I took great care to match timings, but I didn't expect the interval between codes to match. This is due to the 7-bit tick counter. And here is the final test. Thanks for watching, see you next time.